The universe is unimaginably vast. Our galaxy alone contains hundreds of billions of stars, many of them orbited by planets that could, in theory, support life. Beyond the Milky Way, billions of other galaxies stretch across space, each filled with countless suns and potential worlds. Statistically, life should not be rare. If intelligent civilizations have arisen anywhere else, we might expect to detect their presence through radio signals, light patterns, or other forms of communication. Yet when we look, we find almost nothing. This is the essence of the Fermi Paradox, named after physicist Enrico Fermi, who famously asked, "Where is everybody?" Despite the vast number of potential habitable worlds, the universe seems eerily silent. Richard Feynman, one of the greatest physicists of the 20th century, would approach this problem with curiosity and precision, focusing on what is observable rather than what we hope might exist. The silence is not a philosophical puzzle, it is a scientific one. It forces us to consider probability's scale and the limits of our perception. Even if life is common, the distances between stars and galaxies are so immense that signals would take thousands, millions, or even billions of years to reach us. Civilizations may appear and disappear across cosmic timescales, and our brief moment of existence may not coincide with theirs. Our methods of detecting life are limited to the kinds of signals we understand, like radio waves, but intelligent beings may communicate in ways we cannot yet imagine. The universe may not be empty at all, it may simply be operating on a scale or in ways beyond our comprehension. Thinking about this can be uncomfortable because it challenges our intuition. We tend to assume that if something exists, we should be able to detect it easily, but the universe operates on scales and probabilities far beyond our everyday experience. The quiet we perceive is not necessarily proof of absence. Instead, it may reflect our tiny slice of space and time, our technological limitations, and the vast complexity of the cosmos. The silence of the universe is, in its own way, a profound invitation to look deeper, think bigger, and confront the strange and beautiful realities of a cosmos that is far more mysterious than we can easily imagine. To understand the silence of the universe, we need to consider what we actually know about life and the cosmos. We know that the building blocks of life, atoms, molecules, and chemical reactions exist throughout the universe. We know that planets orbit stars in zones where liquid water could exist, making them potentially habitable. We know that intelligent life arose on Earth, showing that under the right conditions, evolution can produce complexity, curiosity, and technology. We also know that civilizations capable of broadcasting signals, like radio waves, have only existed on Earth for about a century, which is a blink of an eye compared to the age of the universe. From these facts, it seems reasonable to expect that somewhere, sometime, other intelligent civilizations should exist. Yet when we scan the skies with our radio telescopes and search for signals through projects like SETI, the silence persists. One reason is the sheer scale of space. The distances between stars and galaxies are so vast that even signals traveling at the speed of light take thousands or millions of years to arrive. Another reason is timing. Civilizations may rise and fall, sometimes disappearing before their signals ever reach another intelligent species. Our own existence is only a brief moment in cosmic time, and it is entirely possible that intelligent life elsewhere does not overlap with us temporally. Technology may also limit our ability to detect life. We are only beginning to understand the many ways an advanced civilization might communicate. They may use technologies far beyond our comprehension or wavelengths we do not currently monitor. Even if they are transmitting, their signals may not be strong enough to reach us across the vast void of space. Feynman would emphasize that these are not guesses. They are observations and logical conclusions based on what we know. The universe is not failing to communicate. It is simply operating on a scale and according to rules that challenge human intuition. Our minds are accustomed to the short distances and lifespans of life on Earth, not to billions of light years or billions of years of cosmic history. The silence is a reminder that the universe is vast, complex, and indifferent to our expectations. It forces us to confront the limits of our understanding and to recognize that our perspective, though valuable, is infinitesimally small in the grand scheme of the cosmos. To grasp the cosmic silence, let's take a thought experiment and imagine seeing the universe from a different perspective. Suppose you could shrink down to the size of a planet and observe the galaxy from that vantage point. Suddenly, Distances that seemed vast from Earth now become tangible. But even at this scale, the universe is immense beyond comprehension. Stars are scattered across unimaginable voids, and planets that might host life are separated by thousands of light years. Even if civilizations exist, their signals may never intersect with ours simply because of the enormous distances. Imagine two civilizations trying to communicate across a galaxy. Even if they broadcast signals continuously, it could take tens of thousands of years for those signals to travel from one system to another. One civilization might emerge, flourish for a few thousand years, and vanish long before the signals reach the other. From our human perspective, this creates a deafening silence. Now consider timing. Civilizations may appear and disappear at different points in the cosmic timeline. Earth itself is only a small blip in a universe that has existed for over 13 billion years. We are observing the universe in a very narrow window of time. Even if life is abundant, our chances of detecting another intelligent species during this window may be infinitesimally small. Technology adds another layer of complexity. Our methods for detecting life are limited to the tools and wavelengths we can perceive. Advanced civilizations may communicate using methods entirely beyond our understanding, like neutrinos, gravitational waves, or quantum signals. From our perspective, they would be completely invisible. Feynman would argue that the apparent silence is not a failure of the universe. It is a reflection of our own limitations. The cosmos operates on scales of space, time, and technology far beyond what humans naturally comprehend. Our intuition, developed for survival on a single planet, struggles to grasp distances of thousands of light years or timescales spanning millions of years. What seems like emptiness may be full of activity beyond our perception. The silence is therefore both real and illusory. It is a reminder that the universe is far stranger than our senses suggest, and that our ability to detect and understand other civilizations is constrained not by the absence of life, but by the vastness of space, the flow of time, and the limitations of human perception. By stepping back and thinking in these terms, we begin to see why the cosmos feels quiet and why this silence challenges our most basic intuitions about the universe. Despite everything we know, there is still an enormous amount we don't know about the universe and the silence we perceive. We don't know how common life truly is. We don't know whether intelligent civilizations are rare or if they arise frequently but fail to survive for long periods. We don't know what forms advanced life might take or how such life might communicate across cosmic distances. Even the physics of communication itself introduces limitations. Electromagnetic signals, for instance, weaken as they travel through space. Over thousands or millions of light years, even powerful broadcasts may dissipate into the void, becoming undetectable. Our tools, such as radio telescopes, can only capture a narrow range of frequencies, meaning we might entirely miss signals that exist outside the spectrum we observed. Feynman would remind us that the unknown is not a failure of science. It is the frontier of science. The more we measure and observe, the more questions emerge. And this silence is a perfect example. Another unknown is the lifespan of civilizations. On Earth, technological civilization has existed for only a tiny fraction of our planet's history. It is possible that intelligent life elsewhere rises and collapses on similar brief timescales, leaving only faint traces that are extremely difficult to detect. The universe might be full of civilizations, but at different moments in time, separated by millions of years. Timing alone could explain the apparent silence. Furthermore, we do not know whether other civilizations intentionally avoid broadcasting their presence. Perhaps they recognize the dangers of revealing themselves, or perhaps their understanding of physics allows them to communicate in ways completely invisible to us. Humans struggle to explain this silence because our intuition is grounded in direct experience. We evolved to understand small distances, short timescales, and immediate cause and effect relationships. The universe operates on distances and durations that are completely outside this realm. To bridge this gap, we must rely on mathematics, probability, and careful observation. Even then, our conclusions remain tentative because we are attempting to infer patterns from a tiny sample, our single planet in one galaxy at one point in time. This limitation makes the silence of the universe a profound scientific mystery. It is not simply a lack of evidence of life, but a reflection of the vast unknowns, the limitations of observation, and the scale of time and space. Understanding these unknowns forces us to rethink our place in the cosmos, to accept that the universe is far stranger than everyday experience suggests, and to embrace curiosity as the primary tool for exploring reality. So, what can we truly learn from the silence of the universe? First, it teaches humility. The universe is unimaginably vast, and our existence occupies an almost insignificant fraction of space and time. We are a small civilization on a tiny planet orbiting an average star in a galaxy among billions. From this perspective, it is entirely reasonable that we have not yet detected others. Second, the silence challenges our intuition. Human minds are excellent at understanding the immediate world around us, small distances, short time frames, and direct cause and effect. But the cosmos operates on scales far beyond our natural perception. Distances between stars are measured in light years, and the lifespan of civilizations may span only a fraction of cosmic time. Feynman would remind us that this is not a flaw in our thinking. It is a feature of the universe itself. The cosmos is not obligated to conform to human expectations. Third, the silence invites curiosity. Each unanswered question opens new avenues for exploration. It forces us to develop better tools, think in probabilistic terms, and imagine possibilities beyond our current understanding. Projects like SETI, the study of exoplanets, and advanced astrophysical surveys are all responses to this curiosity. We may not yet know the answers, but the pursuit itself reveals profound truths about the universe and about ourselves. Finally, the silence offers a deeper philosophical insight grounded in science. It suggests that reality is far stranger than it appears. What we perceive, the twinkling stars, the night sky, the seemingly empty space between galaxies, is only a fraction of what exists. The universe is teeming with complexity, governed by laws and processes that often defy intuition. The absence of detectable signals does not imply emptiness. It highlights the limits of human perception, the vastness of time and space, and the subtlety of cosmic phenomena. Embracing this reality changes the way we see ourselves. We are not insignificant in a despairing sense. Rather, we are participants in an intricate and awe-inspiring system capable of understanding glimpses of a universe that is otherwise silent and unknowable. The cosmos may be quiet, but it is not lifeless in its mystery. Its silence is a teacher, urging us to look deeper, think bigger, and appreciate the extraordinary scale and beauty of reality. In contemplating this, we begin to think like Feynman with honesty, curiosity, and a relentless desire to understand, even when the answers remain just beyond our grasp.